VLANs. Virtual LANs are really the first sign of virtualization that came to networking. Before virtual LANs, you ended up having a whole switch as just one broadcast domain. So that meant that you had routers everywhere. That if you had two computers connected to the same switch, those were in the same broadcast domain. So they were in the same subnet. That a virtual LAN allowed you to carve up a switch such that different ports on that switch could exist in different broadcast domains, and that now you could trunk those as well, but we'll talk about that in the next video. First, let's go ahead and just talk about the beginning here of the LAN, the local area network. So this was originally made up of just layer 2 switches, right? Is that you had these ports here that are all in the red VLAN there, or not VLAN, the red subnet there, and then you had this ports on this switch that are all in the green subnet there, and then over on this guy on the right you had all these ports that are in the blue subnet over there, and that you needed to have a router in between them here in order to split out and separate these broadcast domains on each side of it. This really made it such that you clumped your staff together. Say this is the accounting department over here, and this is the marketing department over here, and this is the IT department over here. And that you needed to have all of your IT computers connected to this switch, and all of your accounting computers connected to this switch, and your marketing computers over here. And you had no freedom to just move one of these guys over here, because now he would be connected into an accounting switch, and he would end up being on the accounting subnet there, that you couldn't intermingle this and just assign the port to be in a different subnet, because you had to go through the router. That whole switch was an accounting switch. This whole switch was a marketing switch, and this whole switch was an IT switch, and that you couldn't get around that these were just one broadcast domain. So step onto the stage, the virtual LAN. The VLAN allows us to take this one switch and split it up into multiple broadcast domains. It kind of splits it up into multiple logical switches. Now, this isn't like the virtual device context on a Nexus switch where it actually has its own routing table and things like that. This just allows you to take, say you have a couple of ports here that are in the red subnet, and then let me get my other color here. Then you also have a couple of ports here that are in your green subnet. And then if we go over here, you've also got a couple of ports that are in your blue subnet. That those could all be intermingled on the same switch here, because now you can separate out different ports into a different broadcast domain. That when a red broadcast comes through here, it's only going to go out the red ports, and if a green broadcast were to come out, it'll only go out the green ports, so on and so forth. And this made it so now you really have a VLAN for your department, is that you have an accounting VLAN and a marketing VLAN. And if you wanted to move a computer here from this switch over to this switch over here, great. You could just pop him onto a port and put that port into whatever VLAN that you needed that computer to be part of, and that there you go. It allowed for a lot more freedom for you to be able to situate your office however you wanted, and honestly, it simplifies things a lot more as well, in my opinion, that rather than just having a whole physical device dedicated for one subnet, you can split it out, and it allows for a lot more freedom here, and it makes more logical sense, in my opinion. So let's talk about the ranges of VLANs that you can have on Cisco devices. So there are 4,096 VLANs that you can use, 0 through 4095. There are a few reserved ones. VLAN 1 is a default VLAN that you cannot delete on Cisco devices. VLANs 1002 through 1005 are also defaults for older technologies, for FDDI and Token Ring. You cannot delete these. You can use them, but you can't delete them. They're reserved. The standard range for VLANs is VLAN 2 through 1001. Now, the reason why this is the standard range is because this is what's propagated with VTP. Now, VTP is the VLAN trunking protocol. The exam topics don't actually mention VTP at all, but I would like to just sort of let you know briefly what this is. Say you've got your switch here, right? And you've got VLANs 1, 5, 7, 10, 22, 36, and 40. And great. And you've got another switch here, right? And he's connected. And you've got another switch here, and they're connected, and these are connected, and you've got another switch over here, and he goes down to a switch over here and a switch over here and connects over to a switch over here, and there you go. And let's say maybe they're connected here. Great. Now you have these VLANs and you want to go ahead and get them on all of these switches. Well, I mean, it's going to be a little bit of administrative overhead to jump into each one of these individual switches here and configure VLAN 5, 7, 10, 22, 36, 40, and to go into each one of these. And then say now you got Spiffy and you wanted to go ahead and add a VLAN 50 on there. Great. Now you need to jump into every one of these switches and add VLAN 50 onto there. That VTP is a protocol that allows for these switches to all communicate that information, as they can go ahead and talk, and as long as they're in the same VTP domain and the authentication information is right depending on the version of VTP, then this set of VLANs will go ahead and propagate out and just show up on all of these switches. Now, mind you, there won't be any port configurations. If you need any ports inside of these VLANs, that configuration won't actually propagate through at all. But these inter-switch links should be trunks, and we'll talk more about that in the next video. But these should all be trunks and members of all VLANs by default. So you'll have layer 2 connectivity end to end here, from end to end, through all of these inner switch links automatically by just adding this VLAN onto your VTP server. And it's just one of your switches will act as a VTP server, so when you make changes to that one, those changes are propagated out towards all the others. And that's how VTP works. Now, we're not going to go into more detail about that here because, like I said, the exam topics don't mention VTP at all, so you don't really need to know this, or at least you shouldn't, and that I just want to let you know how VTP works in case you ever run into that here, so you know what it is. So these are the VLAN ranges. I would make a point to know that 1002 through 1005 is a reserved range. VLAN 1 is your default VLAN, and that you cannot delete these, and that you can have 4096 total VLANs from 0 to 4095. And that those two as well are reserved. That I would know these things for the exam and make sure you commit this to memory. So let's go ahead and jump on over to the lab for a little bit here. Let's go ahead and open up GNS3 and take a look at our topology. So we've got PC1, switch 1 and 2, and PC2 over here on this side. So PC1, I've already gone ahead and configured the IP address 10.1.2.1/24 on the Fast Ethernet 00 interface. And on PC2, I've also configured 10.1.2.2/24 on the Ethernet 00 interface. And that what we want to do here is, I haven't done any real configuration to switch 1 or 2, is that we want to go ahead and take VLAN 50 and create that on switch 1 and switch 2 and put Ethernet 00 on each of these switches into VLAN 50 so that PC1 and PC2 are in the same broadcast domain, right? So let's go ahead and do that. First, I'm going to jump over to PC1 and just show the configuration we have, and then let's jump on over to switch 1 and 2 and get that going. So first, over on PC1 here, is that if we do a show IP interface brief, we see that we do have our fast Ethernet 00 with 10.1.2.1, and that it is up, so I've done a no shut on this interface. So then let's go ahead and jump on over to switch 1 first. First off here, if the command for seeing what VLANs you have is show VLAN. Now this shows your VLANs up here, what ports are access ports in that VLAN, and the VLAN number, the name of that VLAN, and the current status of that VLAN. Now there is also a bunch of information down here with your MTU for the VLAN and your ring number for token ring and things like that. We don't really need this information here. So if you just don't want to display that, you can do show VLAN brief. And that'll just show us the VLAN numbers, names, your ports, and the status. So Ethernet 00 is an access port in VLAN 1 right now, so we want to go ahead and put that into VLAN 50. So if we go config T, interface Ethernet 00, and then let's do switch port access VLAN 50. Now, we didn't create this VLAN yet, but the switch is going to be nice enough to go ahead and create it for us. That it's saying that this VLAN that you tried to put this port inside of doesn't exist, but you want to put a port in it. Great, I'm going to go ahead and just create it for you here. Awesome. So now if we do a do show VLAN brief, then we see we've got our VLAN 50 here. It just gives us a default name of VLAN 0050. And that we now have our Ethernet 00 inside of that VLAN. Awesome. So let's jump on over to switch 2 here. And on switch 2, if we do the same thing, show VLAN brief, we've got our VLAN 1, all of our ports are in VLAN 1, and we've got our default VLANs there as well. So let's go config T. And here, let's go ahead and create the VLAN. If we go VLAN 50, and that's how you create a VLAN, is you do VLAN and the number of the VLAN, and that creates that VLAN on the switch. Here, you can also specify the name. If we want to call this the accounting VLAN. And then, if we do a do show VLAN brief, we've got 50 is our accounting VLAN. Now, interestingly enough, I've found that if you set the name and you do not exit first, it hasn't shown this up here. That's hit or miss depending on what switch you're on. Sometimes it takes effect immediately, other times you have to do exit to exit out of VLAN configuration mode before you'll end up seeing the name actually change here. So now that we have VLAN 50 there, let's go to interface Ethernet 00 and do switch port access VLAN 50. Let's go end show VLAN brief. Great. We've got Ethernet 00 here, and that we also have Ethernet 00 over on switch 1 as in VLAN 50 as well. Let's jump on over to PC1 and see if we can ping PC2 right now. So if we go ping 10.1.2.2, now it's pretty usual, you know, maybe the ports are going through some configuration changes, then we should maybe just do this one more time and make sure that that is not going to go through for us. And it is not. Interesting. So the sharp-eyed of you might have noticed that we have here that our Ethernet 00 on each of these switches is in VLAN 50. However, that broadcast domain is not extended to between the switches. That I did go through and I configured switch port no negotiate, or I configured this interface on each side as an access port so we do not have a trunk between them two. We'll talk about what trunking is in the next video when we go over our .1q fundamentals and how frame tagging works to be able to do inter-switch communication and trunking of VLANs between switches. But this interface here is just an access port and it's still in VLAN 1. So when we send our ARP out from PC1 over to PC2 when we send our ARP out to say, hey, 10.1.2.2, what's your MAC address? That it's never getting over there. It's a broadcast, right? So we broadcast it out in VLAN 50, and this Ethernet 00 is the only interface that's in VLAN 50. So what does a switch do when it receives a broadcast? It sends it out all ports that are in that broadcast domain, that except for the port that it came in on, right? So there are no other ports on this switch 1 that are in the VLAN 50 broadcast domain. So since it came in on Ethernet 00, that frame just comes in and dies and does nothing else. So we need to go ahead and put Ethernet 01 on switch 1 and switch 2 into VLAN 50, and hopefully that will resolve our connectivity problem here. So let's go ahead and take care of that real quick. So over on switch 1, let's just go to interface Ethernet 0/1, and that is something is from interface configuration mode and some other configuration modes. You can just jump directly into another interface without having to do an exit out of interface configuration mode first and then into your interface. Just a little iOS tip there. So here we're going to go switch port access VLAN 50. And then now let's go ahead and do that on the other side as well on switch 2. Interface Ethernet 0/1, switch port access VLAN 50. Now you notice here that it did give us a native VLAN mismatch with our CDP. That CDP was exchanged between the two switches, right? And when I had one of the ports in VLAN 50 and the other in VLAN 1, that we did get a syslog message here saying that there was a native VLAN mismatch discovered. That although you were getting connectivity because it is untagged traffic, it was coming in onto the wrong VLAN that CDP was exchanging and letting each switch know what VLAN that their ports were inside of. So now that we've gone ahead and set those inner switch links here, the Ethernet 01 into VLAN 50, let's see if we're able to ping between PC1 and PC2. So if we go ping 10.1.2.2, boom, works without a problem. That we are indeed able to ping between the two now because we do have end-to-end connectivity in the same broadcast domain, that all of these ports are now in the same VLAN. Awesome. Now, just like the other sections, let's go ahead and run through a few practice questions before we end off here today. First up, what is the default VLAN that all ports are a member of on a switch? This should be one that you have ready right off the back of your hand, and that is a VLAN 1 is the default VLAN that all ports on a switch are a member of when you pick it out of the box. And secondly, what is the command to set a switch as an access port in VLAN 20? Is it port access 20? Do you just go into VLAN 20? Is it switch port access VLAN 20 or access VLAN 20? And this is at interface configuration mode. The answer here is C, switch port access VLAN 20. Now, I hope this has been informative for you, and I would like to thank you for viewing.